All right, good evening. Welcome back to Calculus 2. We are continuing our discussion about trigonometric substitutions here. So we have the integral of dx over x squared times the square root of x squared plus 9. Okay, because we have a plus here, thinking about, again, we have a square root of a square, so that's screaming at you, use a triangle. And there's pluses in here, so I'm going to say that this piece here is going to be my x, and this piece here is going to be my 3. So my square root is going to be x squared, my hypotenuse rather, it's going to be the square root of x squared plus 9, a squared plus b squared is equal to c squared. Okay? And then this will be my theta here. It's an indefinite integral, so we have a plus c at the end, so we've got something like that. All right, let's go ahead and figure this out. So we have tangent of theta is equal to x over 3, or x is equal to 3 tangent of theta. Dx would be 3, the derivative of tangent is going to be secant squared. So 3 secant squared theta d theta, right? So we have that. Since we have x is equal to 3 tangent theta, we know that x squared is going to be 9 tangent squared theta, right? And I think we're about ready to start putting some things in here. I'm going to do one more little thing here. I'm going to say that cosine of theta, looking back at my triangle, that's going to be adjacent over hypotenuse. So it's going to be 3 over the square root of x squared plus 9. Okay. So just knowing, like, we can substitute various things in here. A lot of times people will go ahead and say x is equal to 3 tangent theta and replace all of the x's with 3 tangent thetas, which is fine. You're absolutely allowed to do that. Sometimes you have to clean this up a little bit. So I like to go and avoid that. But that is usually the safer option, is to replace all of your x's with x equals 3 tangent theta and deal with it that way. All right, that's the safer route. So what we have here is we have our dx, which was going to be 3 secant squared theta d theta. We have our x squared. We have x squared is going to be 9 tangent squared theta. Okay. And then I still have a square root of x squared plus 9 sitting here. And I'm going to say, well, look at this. We have a 3 over an x squared plus 9. That's a cosine, right? That's why I set that up for us to be able to look at. So we have integral of 3 over x squared over 9. So this 9 I'm going to pull outside. So it's going to be a 1 over 9 here. We have a cosine of theta times a secant squared theta d theta divided by a tangent squared theta. Okay, so that's what we have so far. I'm going to go ahead and remember that cosines and secants undo each other. There's a reciprocal function. I should say undo. They cancel each other. So we have a 1/9 integral. We have a secant up on top here divided by a tangent squared theta d theta. Let's go ahead and we've got we've got stuff that's kind of in the middle. What we're going to do is we're going to change everything to sines and cosines and hope for the best. So that's going to be 1 over 9 integral. We have a 1 over cosine theta, that's my secant, times cosine squared theta over sine squared theta d theta. So one of my cosines cancels, so I ended up with 1 over 9, and then here we go, integral of, looks like cosine theta on top and a sine squared theta on the bottom, d theta. Again, indefinite interval. So for this one, we're going to say let u equal sine theta. Okay, du would be cosine theta, d theta. Okay, so this piece here, I'm going to wrap this around. I'm going to say, oh, that's my du. So here we have 1 over 9 integral cosine theta d theta is a du. And then we have u to the negative 2 for my sine. Well, this goes back to being power rule. I like that. So let's go ahead and say that's going to be negative 1 over 9 u to the negative 1 plus c. Well, what was u? U was sine. So we have negative 1 over 9 sine theta raised to the negative 1 power plus c, and then we're going to say that's negative 1 over 9. That's cosecant of theta plus c. And then I go back up to my triangle. I was like, what the heck is cosecant? right? Cosecant is a hypotenuse over opposite. So that's going to be the square root of x squared plus 9 divided by x. So here we go. It's going to be square root. So we have the square root of x squared plus 9 over, we've got negative 9x on the bottom plus c, and now we are back into the x world, and that would be our answer. Okay, so we can go back and plug in x limits if we wanted to, that would be fine, but that would be a general answer. Like that's pretty nice of the problem. I like that. Pretty good. Okay, let's move on to the next one. This one's not going to be so much fun. So we'll have a definite integral from 0 to 1. Okay, here we have an x squared plus 1 raised to the 3/2 power dx. So again, you have to remember that this is equal to 0, 1, x squared plus 1. And I'll go ahead and write this as a square root so we can see it cubed, right? Because 3/2 needs a square root dx. So again, here we have square root of a square, which is screaming at us, please use a triangle. I mean, not all the time, but many times. And since we have a plus here, we're going to be able to say this is a squared plus b squared. So we can go ahead and set this up. Fortunately, one of the answers is, one of the sides is 1. So if I added these things together as Pythagorean theorem, we're going to say this is going to be x squared plus square root of x squared plus 1. Here's my theta. Okay, so again, here we have the tangent of theta is equal to x over 1. X is equal to the tangent of theta. So my dx, right, is going to be secant squared theta. Right? And that's what we have for that. So that's looking pretty good. All right. So let's see here. My secant theta is equal to the square root of x squared plus 1 all over 1. So secant cubed theta is going to be x squared plus 1 raised to the 3/2. See, I'm going with this now, don't you? All right, so let's go ahead and figure out what we're doing here. So we have our x equals 0 to x equals 1. I'm going to leave it and the x coordinates and the x limits for the entire problem for this one. So here we have secant cubed theta, right? Because that's my 3/2 times dx. So that's going to be secant squared theta d theta. Let's put a d theta in here. Okay. So looks like we get to integrate secant to the 5th power. That sounds like so much fun. Okay. Okay, so we have secant to the 5th power. That seems delightful. All right. So let's go ahead and say, break this apart. So we're going to say this is secant cubed theta times secant squared theta. I kind of like this as an integration by parts. So we'll say let u is equal to secant cubed theta, because we have to take a derivative. Like, oh, I could take a derivative of this. That's going to be 3 secant squared theta times the derivative of secant, which is secant theta tangent theta. And then my dv is going to be secant squared theta. So my v is going to be tangent theta. So here we go with our swish and flick here. So we have our diagonal times the bottom row. So we have secant to the 5th, 0, 1. Secant to the 5th d theta is equal to, we have secant cubed tangent theta minus the integral of 3 secant, let's see, we have 1, 2, 3 secants, so secant cubed, and we have 1, 2 tangents, so we have tangent squared theta. Okay, and we have to integrate this piece. So next thing we're going to do is we're going to say, wait a minute, tangent, fancy way to write tangent. So we have sine squared plus cosine squared is equal to 1. Divide everybody by cosine squared. We have tangent squared plus 1 is equal to secant squared. So tangent squared is equal to secant squared minus 1. Let's go ahead and replace that. So we have the integral of secant to the 5th d theta is equal to secant cubed tangent theta minus 3. And now we have a big thing going on here because we have the integral of secant cubed times secant squared minus 1 d theta. Okay, So let's go ahead and multiply that together. So we have integral of secant to the fifth d theta is equal to secant cubed tangent theta minus 3. Well, if we multiply these together, we have integral of secant to the fifth theta d theta minus secant cubed theta d theta. This is all on the side of an integral. Okay, actually, I'm going to go ahead and use the linearity of integrals to go ahead and distribute this integral sign to both of these terms. Okay, so let's go ahead and figure that out. Oh, wait a minute. We have a secant to the fifth on both sides. Why don't we go ahead and add 3 integrals secant to the fifth power on both sides? So we have 3 integral secant to the fifth power d theta. And then what we're going to have here is we have 4 integral secant to the fifth power d theta is equal to secant cubed tangent theta. Let's see, this is going to be a plus 3 because negative times negative is going to be a positive. And we have integral of secant cubed theta d theta. Now, I told you that secant cubed is another one of these tricky integration by parts that kind of loops around on itself, which we just did. And you probably be best served by memorizing it. You only have to demonstrate it for me once. After that, you can say, oh, by a previous problem, you go ahead and remember that. So I always remember secant cubed is equal, the integral of secant cubed is equal to the average of the derivative of secant plus the integral of secant. So we're going to say this is 4 integral secant to the fifth theta d theta here is equal to secant cubed tangent theta plus 3. And I'm just going to integrate this in one little spot here times 1/2. And now we have secant theta tangent theta, that's the derivative, plus the natural log of secant theta plus tangent theta. Okay, and that's what we have for that piece. Okay, plus c. So we've got a little bit of stuff to clean up here. It's not going to be too bad, but it's a little bit. So let's have a check to make sure we've got that going on. Okay, let's see here, that previous problem, right? So we can go ahead and shift this guy off. So let's go ahead and write this guy down. So we have the integral of secant to the fifth theta d theta is equal to 1/4 secant cubed tangent theta plus 4 times 2 is going to be 8. So I'm going to have a 3/8 secant theta tangent theta plus 3/8 ln of secant theta plus tangent theta. Okay, all of this plus c. Okay, that got rid of my 4 that was on the other side. We just have this piece here. And now we have to go back up to my triangle. Remember that started off as a triangle? And we can remember that the secant is equal to the hypotenuse divided by the adjacent. So that's going to be x squared, the square root of x squared plus 1. Okay, so let's go ahead and start figuring out what's going to happen here. So we have 1/4. We have the square root of x squared plus 1 raised to the 3/2. What was the tangent of theta? Tangent of theta going back up to my triangle is just going to be x. So let's go ahead and just write that down as an x. We could even be clever and cheat it that way. Say it's x/4, x squared plus 1 raised to the 3/2, plus 3/8. Here we have x squared plus 1 to the 1/2 times x plus 3/8 natural log of, and then secant was going to be x squared plus 1 raised to the 1/2 power plus x. Oh, it's not plus c. We're going from 0 to 1 because we had a definite interval, didn't we? Well, we did. Yeah, we sure did. Let's go all the way up there. So let's go ahead and plug in a 1. So we're going to say this is equal to 1/4. 1 squared is 1 plus 1. So we have 2 raised to the 3/2 power here plus 3/8. And then here we have 2 raised to the 1/2 power. So that's kind of the square root of 2. All right, times 1 plus 3/8 natural log of, now we have 1 plus 1, so we have the square root of 2 here, plus 1. All right, that's nice. We don't need the absolute values because the square root of 2 plus 1 is a positive number. All right, so let's go ahead and clean this up a little bit. So we're going to say that this 2 to the 3/2 power is going to be 2 to the 4/2 times, oh no, I'm sorry, 2 to the 2/2. It's this. 2 to the 2 halves times 2 to the 1 half. That would be 3 halves. So 2 to the 2 halves is going to be 2. Okay, so we have 1 over 4 times 2 square roots of 2 plus 3 over 8 square roots of 2 plus 3/8 natural log of, let's do parentheses, square root of 2 plus 1. And we'll go ahead and say, let's multiply by 2 over 2 to get a common denominator. So we've got 4 roots of 2 over 8 plus 3 roots of 2 all over 8 plus 3 over 8 natural log of square root of 2 plus 1. So that's going to give us 7 root 2, okay, all over 8 plus 3/8 natural log of square root of 2 plus 1. And that is the answer that I got because I chugged this into Desmos as well and made sure that it actually worked. And that's the answer we got. So that's how you do a problem like that. Again, you'd be best served by memorizing the integral of secant cubed. You have to show me how you do it once, but after that, you can use the fact that you memorized it over and over and over again. Easy way to remember, it's the derivative, it's the average of the derivative and the integral of secant, and that will help you out for memorizing that, and that'll be really good. So that's an extra couple of those problems. We'll do some more. Thank you very much for watching the video. I will see you in the next one. And until then, take care.